Smart Nadal. Yesterday we rebuilt an entire database from scratch in under 30 minutes, so I today thought it would be appropriate in 5 minutes to rebuild from scratch all of React. I'm kidding. That's a joke. There was a chunk of my talk that I had to cut out because I didn't have time for. However, I went out showing it to the organizers, and they thought it was so compelling that they invited me back on stage. So thank you very much for that. You guys have been fantastic to show you what you missed. So we made claims about the scalability of the system, but we didn't actually verify that. We didn't actually test it. So we're going to do that today. We're going to run a distributed systems test against the code we wrote yesterday. Everything's the same except for, well, these 2 lines that I changed, but they're not that important. Just fs.write file. Oh wait, let's run the test. We're actually going to run this test using Mocha, even though it is a distributed systems test. So it's going to do some things, but then it's going to prompt me, oh wait, open 2 browsers. Oh, what is this? Okay, let's go over to the browsers. Let's refresh that one. These 2 browsers are going to connect to each other and perform load tests against each other. They're going to sync 25,000 records between each other. And we are off and running. So as this is running, we are verifying. There's actually a bug that this caught the other day, and I'm still trying to figure out, oh, okay, we're already done. We've just verified 25,000 table inserts to each browser. And we did that right here in 9 seconds. So not only did it test the correctness of the system, number 1, but we can also then use that timestamp to say, hey, 25,000 records divided by 9.2 seconds means we're doing about 2,700 table inserts per second across this ad hoc mesh network multi-replicated database that we built yesterday. This is the same code that we built yesterday. Now, how does it work? Okay, let's jump into, well, we're just using Mocha, which is interesting because you're actually able to take this test and distribute it across not just this one machine, any remote machine we can test against as long as it knows my IP address. So it actually disclosed my IP address earlier, so if you guys connected, it would run tests, but please don't do that while I'm on stage. So the test just starts with configuration, which is like, hey, like how many browsers are going to spin up? How many the servers are going to spin up? And then how many records is each browser going to sync? I didn't actually show you that. I do want to show that the data did go to the storage that we built yesterday. You know, yesterday you only saw the exclamation mark, but I talked about how if the file becomes too big, we actually split it into other files, and that's what it did. That was the code we covered yesterday. Anyways, okay, so back onto the Mocha test. The Mocha test has a couple configuration, and then Panic server. Panic is our system that allows us to conduct chaos or panic into our system. It just lets us right here spin up a server so we can send these static assets down to the browser, but it's got this magical property called clients on Panic. And this lets us detect all of these separate peers that connect to the Panic server. And in this case, we're actually telling the Panic manager to generate some servers. In this case, it's just the one server. And then we can say, hey, of all the clients that are connected, let's filter the ones that are Node.js that we know that it is the server. And all the ones that are not servers means it's the browser. And now we start writing our Mocha test. Describe.it. And this actually works with other tests like Jasmine and stuff like that, other test runners. So the first test we have is just make sure that we have the server connected to Panic. The second test is, once we have the server connected, tell that server to actually run the communication module that we built yesterday. Then the next test is saying, well, at least verify that we have the peers, the browser peers that we expect connected, at least 2 connected. Then this is where it gets fun. Now, save and sync the data across the browsers. We're going to put an ID for each browser, and we're going to say, for each browser, run this test. But this is where it gets trippy. The code, this callback here, is actually going to get deployed to a remote machine or to the browser and run in the browser, even though we've written it in a Mocha test in a sequential steps, it is getting deployed out to that. It makes it really easy to write distributed systems and verify that they're correct. All in JavaScript, yes. So this code is what we had before, which is just the browser side. You know, we peer connect, blah, 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 check and track, do the deduplication mechanism. If we have a put, mix it into the graph. And the only thing we've changed here is we've added that every single time we receive an update, run it through the verify function. I'll go to the verify function in just a second. We first need to make sure that we deterministically compute how many records we expect to save. And then we're going to create this little checklist, okay, that has a property of 1 on it to say that this is an outstanding value that we need, or an outstanding table insert that we want to check against. And then this is just the report code that showed the the data syncing up there. I'm going to scroll down past verify to show you spam. All spam does is do a set interval, and then it bursts some writes into the system, which is what we did yesterday. We have this graph. We create an ad hoc mesh network envelope, and then we send it out over the peer. And then oh boy, I'm over time. And then the verify function receives it, and it then says if it matches that ID exactly what we want, check it off to say that it's valid. And if every single record is checked off, then we know that the test is correct. So thank you so much, and I should try.